Hey everyone, so my name is Gianmarco Toso and I work as a freelance software developer as well as an IT researcher for a research institute in my hometown of Turin. This talk is going to be about what Francesco was talking about, constraints. Because I am going to introduce some ways to constrain the way you build your applications in a way that allows you to have a structure that doesn't where the complexity of the application doesn't grow with the application itself, but stays mostly flat. I would like to point out that this is my first talk, so here we go. Another important thing that I want to say is that this is just a proposal, so I am not putting down rules, I am just giving you suggestions, but I understand that every use case is different, so I mean, take away from this whatever you need to. You don't have to take away everything. What is the motivation of this talk? Okay, it doesn't work. Okay, it does. What is the motivation of this talk? First and foremost, we want to have code reusability in our projects, because every line of code we write, every component we write, every reducer, everything, we should be able to reuse it. Then we also we also want to be able to work better with our teammates. We want to be able to distribute our work so one teammate can focus on the presentation and another teammate can focus on the business logic of our application. And this is also why we want separation of concern. We want that certain specific parts of our application to handle very specific pieces of code. Some code must be about presentation, some code must be about data, and some code must be about putting the data into the presentation. So what we are going to talk about is mainly these things: the presentation layer, the data layer, and after saying what a presentation layer is and what a data layer is, we are going to try to define modules. After defining modules, we are going to try to see what kind of application structures in terms of file system we can have in our application in order not to have it become a spaghetti code mess. This is a very, very, very simplified representation of a Redux application structure, but I think it gets to the point. We have a unidirectional data flow where the data from the store gets in some way sent to the presentation layer. The presentation layer does present the data, and when the user interacts with the presentation layer, we have the data going back through an action and a reducer to the store in a single direction. But I am not here to tell you about how Redux works. I think most of you already know how Redux. How many of you use Redux in your applications? Okay, a very good percentage, I see. What I am here to talk about is how we divide the concerns of these parts of the application. And as I said, we have a presentation layer, which is quite evident, and in our application is mostly made of React components. And somewhere around here, we have a data layer, which keeps the data safe for us and allows us to interact with it somehow. So what is the role of the presentation layer? Of course, as the name itself tells us, is to present something. Mostly, it must present the data we have stored in a way that our users can understand, and also must allow us to interact with the data through some sort of interface or some sort of way for the user to send actions back to the business logic. What is the role of the data layer? It has three main roles. The first role it must have is to fetch data from somewhere. We do not really care from where the data is fetched. It can be from a remote server, it can be from a local storage, it can be from a file, it can be either fetched synchronously or asynchronously. We do not care. We just know that the data layer must be able to fetch data and must expose some way for us to initiate this fetching. Also, it must be able to provide us with the data it has fetched. So it must expose some sort of surface, interaction surface, where we can get the data we have stored. With React and Redux, this happens by connecting components to the state. Also, we must be able to manipulate the data we have stored. So again, we must have some sort of interaction surface, some sort of API that allows us to send actions to modify this data and maybe store it locally or externally. Again, we do not care where the data is stored. We just need to know that we have a way to interact with it, and we have some layer that takes care of this thing without us necessarily knowing how it happens. Let's take a step back and look at our stack. We have ReactJS, which in our case handles the presentation layer. And it does so by allowing us to create reusable components. Also, it's an awesome technology, and I think we all love to work with it. We also have Redux. Redux is the layer that is a technology that allows us to handle the business logic of our application, and does so by implementing a version of the Flux pattern, which is not pure Flux, but it's mostly Flux as it was defined by Facebook or someone else before them, I think. Also, Redux is awesome to work with. So why not use these two technologies together? We take Redux, we take React, we take 1,000 other modules, which we all know how it becomes when we use NPM, and we have an application stack, a complete application stack, hopefully. And ReactJS and Redux work together by connecting components using the React Redux library. A connected component is basically a normal component, a regular React component, which is given as an argument to an higher order component generated by the connect function, which is provided by React Redux. And is connected to the state through a selector. A selector is defined as a function that returns some part or all the state, usually some part of the state, because we do not want a connected component to be connected to the whole state, but just to fragments of the state itself. Okay, we have seen how an application is structured, and I think I didn't say anything new for most of you. Now, let's try to use this definition to define a module. What is a module? Well, before trying to define a module myself, I would like to look with you at some definitions that people with way more stars than me on GitHub have defined. So we have two notable mentions. The first is DAX, Redux Reducer Bundles, by Erik Rasmussen. And the second one is an article by Jack Su, where he defines rules for structuring Redux applications. Let's take a look at the DAX. Okay, so I am not going to go deep into the definition of DAX, but it's actually quite simple. The DAX proposal explicitly tells us that a module is defined like so. A module must export a default function, which is the reducer. A module must export its action creators as functions, so we can be able to consume them from outside a DAC. And also, it may export some action types, so the constants, the strings that define the actions, as with a specific format. Also, a DAC must have action types in some sort of form that he has defined. I am going to gloss over this point because it's not really relevant with the thing that I am trying to tell you. Also, I do not. How do I say this? The fact that some action types can be exported to be consumed by another DAC, by another module, is something that I would avoid doing, because in doing so we create dependencies between modules. And dependencies between modules make it so that they cannot be reused independently with ease. We must put in some work to break the dependency in some way. The second the second definition of a module, but more of definition of a module as a definition of how an application must be built, is by GrUSP and its rules for structuring a Redux application. In this article, GrUSP tells us that modules must represent a feature. So each module must have its own folder, and within the folder, we must have all the components in a components folder, and then the actions, the action types, the constants, and the selectors and the reducer. As we can see, this is the typical index.js of a module as defined by GrUSP. So it imports all the actions, all the components, all the constants, the reducer, and all the selectors, and it exposes them as its public API. So any other module can consume one or all or some of these parts of the module. One thing that this architecture does, though, is to put everything together. We have the presentation layer and we have the data layer. Everything is put within the same module. So we do not have the separation of concern. We do not have a module that only takes care of the presentation or the data. We have a module that represents a feature, for example, a posts feature, a users feature, an articles feature, and both the presentation and the data are handled by this feature, which makes, Jack says that there should be no circular dependencies and there should be strict module boundaries. The strict module boundaries are defined by the public API, but it often happens when you are building an application that you need to take the same part of the state, the same data, from multiple features, because you are probably going to want to show me a list of articles, and each article should show me also the user that has posted the article, and maybe when the article was posted, and maybe if there are other articles connected to it, and maybe if there are comments, each comment must also have a user connected to it. So it's not like we are not going to have dependencies between modules if we take this sort of approach. So let's try to define a module in a more constricted, bounded way. So what is a module? A module is an independent unit of your application. This is the simplest definition I could come up with, but what can a module do? A module can define a presentation layer. A module can also define a data layer. It can define both. It doesn't mean that it has to define both. Also, a module can depend on other modules, but it should do so as little as possible, because every time, again, we create a dependency between modules, we are losing something. We are not gaining anything. And there are ways to avoid creating dependencies between modules. I want to give you a sneak peek of our application, of how our application should look like. As you can see, we have 3 layers, very distinct layers. Each layer has a very specific purpose. The layer on top is the presentation layer, which has many presentation modules, which are independent from each other. On the bottom layer, we have data sources, which are, again, modules, which only do work with data. They do not do anything more than give us an API to interact with the data and to fetch the data and to use this data. How are the presentation modules connected with the data modules? Through a simple data provider layer. A data provider does nothing more than expose some API for the presentation modules to be able to consume the data saved within the data sources. We are going to take a look at each one of these layers and see how we can implement these in our applications. So, as you can imagine, a presentation module is a unit of your application that can contain components, because, of course, it must show us something. It can contain routes, if you want to use React Router or any other kind of thing like that. And it can contain a reducer, some actions, and some action creators, but only and only if these actions and this reducer deal with something that has something to do with the UI. We never put data within presentation modules. We just use reducers, actions, and action creators to modify the state relative to the UI. So as you can see, a presentation module can have this kind of folder structure. We can have components, where each component has its own folder. Then we can have a roots file and an index file to expose the public API of the presentation module. We then have the data source. The data source is a module, just like before. It's exactly the same kind of type of module. It's just a semantic distinction, the one I am making here. A data source is a module that defines how our data is used by our application. So it must contain a reducer, some actions, and some action creators, and also a default state. I like to put default state in a separate file, but of course, you are free to put it within the reducer. It doesn't really make any difference. As you can see, this kind of module cannot have components because it doesn't need to have them. It can just expose a public API to consume the data, fetch it, save it, whatever. Then there will be something else that takes care of connecting this kind of module. I'm sorry, I'm blocking the image. This kind of module with a presentation module. And that is the data provider. A data provider is a fancy word for a higher order component. A higher order component that we can use to connect whichever component we want to our state. And it's nothing more than a call to React+Redux Connect. Okay, you see, what I am doing within a data provider is nothing more than taking all the action creators, defining some selectors, in this case through the use of reselect, and then exporting as a default export the result of the call to connect with the selector I have defined and the action creators I want to expose, which will be bound when they are then used. When I will wrap a component with the result of this function call, the component will find both the data in the props and the bound modules within its props. Okay, so this is what a presentation component looks like. So this is what a simple component connected with our data provider looks like. You see, we just import the data provider and we use it to can you see this? Okay, I do not know how to. Well, it's just export with posts my components. So I call the with posts function using my component, which that's a typo. It should be post lists as an argument. And as you can see, we have the props, which contain our data, and we have a function which I've called add post as a possible function that we can use to interact with the data. The nice thing is that we do not have a direct dependency between the presentation layer and the data layer. We have an intermediate layer that takes care of handling the connection. So we can easily swap out the data source for another one and nothing breaks. We can easily change the data provider, provided that we keep the public API, the component doesn't break. And we can easily test this component without having to with only having to mock the properties. We do not have to either mock either the data provider or the data source. This leaves us the possibility to have one teammate working on the components, one teammate working on the data sources, and someone in your team can just write the data providers as intermediate layers to connect your presentation with your data layer. So again, we can see how the dependency graph is divided, and we can see that a single presentation module can depend on one or on more data providers, and that a data provider can expose one or more data sources. This is because we can, of course, connect a single component multiple times, but every time you do so, you call component over and over again, so it can have an impact on performance if you are going to connect many data sources. So you can have data providers that provide you with data for more than one data source. That's completely acceptable. Okay, so now that we have talked about how we should divide our components, our modules, in a way that we do not have dependencies, in a way that allows us to divide the works among our team, I'm going to try to see how we can structure our our application folders so that we do not go mad when we are trying to maintain this application. Because we all know that as soon as the code begins to grow in a significant way, if the application is not structured correctly, we are going to have a very bad time trying to find where we implemented a specific feature, or if we want to remove a feature or add a feature, it's going to become very difficult. So how can we do so in an intelligent way? Reminding ourselves that an application is not made only by modules, but can also have other things. It can have public styles, global styles, services, utilities, DOM components that we may reuse in our connected components, configuration files, whatever you want. Well, a suggestion that I like to give is that you should have a folder for each different kind of element your application contains. So we have one folder for Bootstrap, which is not the CSS framework. With Bootstrap, I mean all the files your application will call when it starts. So you can have a sync history with store function that you define there. You can have some sort of function that builds your routes. You can have whatever kind of Bootstrap code you need. Then we have a folder for our DOM components, which are most likely to be reused among all the presentation layer of your application. You can have buttons, lists, images, whatever. Then a configuration folder, because you might want to use configuration files for your application depending on the environment you are running the application in. For example, I like to have a development.js file for the development configuration and a production.js file for the production configuration. A core folder just to put inside an application class that handles the application lifecycle. A data folder to put my data sources in. A modules folder to put my presentation layers modules in. A providers folder to put my presentation data providers in. A services folder, an utilities folder, and of course an index.js, which is the entry point for your application. Another tip that I want to give to you, but I have to thank Michele Bertoli for this one, because he is the one who suggested to me, is to have a single folder for each component, and for each component you should have the component itself, the spec, so the tests for the component, the unit tests for the component, the style for the component, and an index.js that you can use to easily export and import your component. And please do not forget to include tests. Okay, so I made a little repository with a boilerplate application that follows more or less this kind of structure. It works, and it's ready to be used. It is very opinionated, just as everything I have presented to you so far. Of course, you can take whatever you need from it and build on top of it, or just take pieces and put them into your applications. It's mostly up to you, because I understand that what I have just said can not necessarily apply to all cases of all kind of applications you are going to build. So these are just guidelines that you can decide to follow if you like them, and if you don't, you cannot follow them. So I was quicker than I thought. That's mostly it. Thank you.